Hi, Jacob. Thanks so much for sending your question. So ideally, we want to simplify these as much as possible before we have to apply things like rules of exponents and all that complicated stuff. The first thing I'm going to do to simplify it is I'm going to get rid of this negative exponent. I know that if there's a negative in my exponent, that my expression with the negative exponent actually belongs on the other side of the tracks, so to speak. So instead of being in the denominator, this guy belongs in the numerator. So let's go ahead and put him there. So instead of 64 to the 2/3 divided by 64 to the negative 1/2, I have 64 to the 2/3 times 64 to the 1/2. There are a couple types of rational exponents you're really going to start to recognize as you go through your math career. And one of those is going to be 64 to the 2/3. Let's break this down a little bit. I've got a numerator and the denominator in this exponent. The numerator is a regular old exponent like I'm used to, but the denominator is actually a square root. So let's go ahead and write it like that. So this is actually the third root of 64 squared times, and let's go ahead and write this second one as a square root as well, since that's actually what it is, times the square root of 64. When I have both a root and an exponent on a base, I can apply whichever one I want first, and ideally you want to apply whichever one gives you the smaller number. I don't know what 64 squared is. I could plug it into my calculator, but I can tell you it's going to be a big number. What I'm going to do is apply the root first. I know that the cubed root of 64 is 4 because 4 cubed is actually equal to 64. So applying the root first, I'm going to pull out 4, and then we'll just stick the exponent on there because I haven't applied that yet. And this is times the square root of 64, which, as I'm sure you know by now, is 8. So here we have 4 squared times 8. 4 squared is, of course, 16, and that's times 8. And 16 times 8 is 128. And that'll be your final answer for this question. Thanks again for your question, Jacob, and I look forward to answering more of your questions using Snap Math in the future.